We want to evaluate each composite function value given the table of values for f of x, the graph of g of x, and the function rule for h of x. In our first example, we're given x equals -2. We want to find g of f of x. And since x equals -2, this should be g of f of -2. To evaluate this composite function value, we begin by determining the inner function value f of -2. So looking at the table of values for f of x, we want to find the output or function value when the input or x value is -2. So looking at the table of values, notice here's where x equals -2, and when x equals -2, the output or function value is +1. Since f of -2 equals +1, this simplifies to g of 1. Now looking at the graph of g of x, we want to find the output or function value, which should be the y value when the input or x value is +1. So looking at the graph of g of x, notice here's where x equals +1. At this point, notice how the y coordinate would be +2, and therefore the function value is +2 when the input is +1. Therefore g of 1 equals +2, which is our composite function value. Next we have x equals +2. We want to find f of g of the quantity x minus 1. And again, since x equals 2, this would be f of g of the quantity 2 minus 1, which would be f of g of 1. Notice here the inner function value is g of 1, so now we'll go back to the graph and determine the function value or y value when the input or x value is +1, which we actually just found. Notice how g of 1 is equal to +2, which means this simplifies to f of 2. So now we'll go to the table of values for f and determine the output or function value when the input or x value is +2. And notice here's where x equals +2 and the function value or output is 0. And since f of 2 equals 0, this is our composite function value. And now for the last example, we're given x equals -1. We want to find h of the quantity f of x minus 3. So we'll first substitute -1 for x. So we would have h of f of -1 minus 3. So we'll begin by determining the function value f of -1 using our table of values for f. Here's where the x value or input is -1. And notice how the output or function value is +3. And since f of -1 equals +3, this would be h of the quantity 3 and then minus 3, which would be h of 0. To determine h of 0, we use the function rule h of x equals x squared minus 3, and since the input or x value is 0, we'll substitute 0 for x. So h of 0 would be equal to 0 squared minus 3, which is -3. So here we have a composite function value of -3. I hope you found this helpful.